All right, Frappy from chapter 6. So we know the mean of the bags is 16.15 ounces. Standard deviation is 0.12. If we randomly select one of these bags, what's the probability the total weight is less than 16 ounces? In the question, they tell me that it is normally distributed. So, here we go. Normal distribution. Mean of 16.5. Here's 16. Boom, 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 boom. If that's the 16, I want to know normal CDF. What is the probability of getting a bag less than 16? So negative 1,000 for a good low bound. 16. The mean is 16.15, sorry, and standard deviation is 0.12. Use normal CDF, I find out that is 0.1057. So the likelihood of getting a bag from this randomly selecting a bag that its weight is 16 ounces or less is 0.1057 or 10.6% chance of that. B, if we randomly selected 10 bags of these chips, what's the probability that exactly 2 of the bags will have a total weight less than 16 ounces? I sense the world of binomial distributions here. Fixed number of trials, 10. Number of successes is defined as 2. The probability of getting a bag less than 16 ounces, we just calculated, is 0.1057. That's for every possible bag. And the number of trials is fixed to 10, and they're independent. So bins, we got it, binomial. So 10 trials, exactly 2. Success is 0.1057 squared versus failures, 1 minus 0.1057 to the 8th is going to give me the answer for this, and it is going to be 0.2057. Can I use my calculator for this? Sure. I'm finding the probability of exactly 2 successes. So that equals binomial. P, exactly, probability. DF of 10 trials, successes 0.1057, and there are 2 successes we desire. Guess what? I'm going to get that, 0.2057. 3. Buckley Farms ships in its boxes that contain 6 bags, ships chips in its boxes. The empty boxes have a mean weight of 10 ounces and a standard deviation of 5 ounces. Calculate the mean and standard deviation of the total weight. Part C. Let's call T the total weight. Guess what? Here we're combining random variables by adding them. So the expected value of T is going to be the mean of the box, that's 10 ounces, plus the mean expected value for 6 of the bags. We expect each bag to be 16.15 ounces, so there are 6 of them. I'm using short form here. The combination in the box is the expected value of the weight of the box plus 6 of the potato chip bags. Gives me the expected value here of 106.9 ounces. Standard deviation of this box of chips. I cannot just take the standard deviations of the individual components and add them together to calculate standard deviation. I have got to find the variance. How do I find the variance? I square the standard deviations. So the standard deviation of the box is 0.05 ounces. So I square that. And then I'm going to add to that, there are 6 bags of chips. The standard deviation is 0.12. So I'm going to square that number and multiply it times the 6 bags. This is the variance of 1 bag. There are 6 bags. This is the variance of the box. This gives me the variance, which is 0.0889. So the standard deviation would be the square root of that, 0.0889, and that comes out to 0.298 ounces. Last part, D in the old Frappy. Buckley Farms decides to increase the mean weight of each bag so that chips only 5% of the bags have weights that are less than 16 ounces. Assuming the standard deviation remains at 0.12, what mean weight should Buckley Farms use? Hey, we have to find the mean. Here's my normal distribution. I want this area to be 5% of the bags, so 0.05. I know that this is 16 ounces that's going to correspond to it. What I don't know is the mean that I need so that 5% of the bags would be less than 16 ounces when, as it says, the standard deviation is unchanged at 0.12. Yikes, how do I work backwards to solve for the mean? This is not inverse norm because I already know the data value that corresponds to the 5%. So I'm not going to use inverse norm. But my gosh, what else have I used in the past where I know the value, the probability, the standard deviation, but not the mean? I'm thinking some z-scores would be good here. But guess what? I know the data value is 16 minus some mean over the standard deviation of 0.12 will equal the z-score. I don't know the z-score. That's where I need to use inverse norm. What z-score corresponds to 5% of the data falling below that? So if I did inverse norm, 0.05, what's the mean of z-scores? 0. The standard deviation? 1. That's going to give me the z-score that corresponds to this. And that is negative 1.645 using inverse norm. This z-score corresponds to 5% of the data values falling below it. So now I've got 16 minus the mean I'm trying to solve for, 0.12 equals negative 1.645. You work your magic algebra. The company needs to set the mean to 16.1974 ounces. That's the mean. Now it's time for a Frappy. A real Frappy with some snow in it. See ya.